Hi there, my name is Ross Goldingay and I'm going to talk to you about squirrel gliders today, and I'm going to consider issues relating to nest box use and population monitoring. Okay, a bit of an outline of what I'm going to cover. I'm going to need to be quick here today. I'll touch on briefly about where we find squirrel gliders and what their status is. Then I'll talk briefly about the need for habitat restoration. I'll give a very brief account of the history of nest boxes in Australia as it relates to mammals. Then I'll talk about nest box contentions. There's been a few debates and criticisms of using nest boxes. And then I'll talk about some of the population monitoring that we've done of squirrel gliders. And then I'll consider what we might do in a post-fire recovery sort of context. Okay, where do we find squirrel gliders? Well, basically they're found up and down the east coast from far north Queensland right through to Western Victoria. And historically, or until recently, there was an outlying population just over the border in South Australia. But the status of that is, to me at least, is still a bit unclear. Now, some genetic work that was done 10 years ago now identified that there's basically a genetic subdivision in the geographic range of the squirrel glider. So somewhere in the middle of New South Wales, it's a bit unclear because of where sample sites have occurred. There is this division. So north of that area, or all the samples north of that, sort of align into one sort of genetic group, whereas south of that, they align into a separate geographic group. And based on some modelling where mutation rates are assumed, it suggests that analysis suggests that this division occurred somewhere at around 50 to 100,000 years ago. So it's a fairly old subdivision or disjunction in gene flow through the broader population. Now, the other thing of interest here is that in Victoria, the squirrel glider is listed as endangered. In New South Wales, it's considered vulnerable, whereas in Queensland, it doesn't have a conservation listing, although in southeast Queensland, it's often used as some sort of flagship or indicator species. So there has been quite a bit of work done in southeast Queensland, partly driven by the conservation status in other states. Now, one thing is quite apparent that in the southern part of the range, the populations are highly fragmented because they occur within agricultural land. So historic clearing has occurred there, so remnant habitat is quite patchy, whereas once you get into northern New South Wales, you're into sort of much broader areas of forest that the species occurs in. The shaded geographic range shown in this map exaggerates basically the extent of the range. Squirrel gliders tend to occur below 300 metres elevation, so anywhere along the Great Dividing Range above that, you're basically not going to find squirrel gliders, but you'll get sugar gliders there. So the shaded area does exaggerate where you're going to find squirrel gliders. Now, moving along, these slides show what some of the landscapes look like where we have squirrel gliders occurring. So the panel on the left showing northeast Victoria, so that older sort of cleared area where the gliders are just hanging on in sort of the remnant habitat, particularly along the margins of roads. So there's quite a lot of quality habitat that has been retained along roadsides throughout rural Victoria. In the central part of the range, let's say in the Hunter Valley, squirrel gliders are fairly patchy. Again, there's been a lot of historic clearing, and then more recently there's been a lot of clearing associated with expansions of coal mines. Once we get up into southeast Queensland, and to some extent this applies along a lot of the coastal areas, there's been a lot of residential development. So this is the thing about a species that occurs at low elevation, that it tends to coincide with areas where there's a, a high sort of requirement for people to change the land use there to housing or something else. Now, just to give you a bit of my background, and I've put this in because I'm going to spend a fair bit of time talking about nest boxes, just to highlight that my background is not nest boxes. I've spent quite a bit of time in old growth forests. So my PhD work was on yellow-bellied gliders in southern New South Wales, so down on the southern tablelands at Bombala, and also on the south coast of New South Wales near a place called Kyola. So I spent quite a few years chasing gliders through the forest down there in old growth forest, and nothing could have been further from my mind than nest boxes at that point in time. Now, just to give you a very brief history of nest boxes in Australia. So with a student of mine, Georgia Bayer, we did a review that was published in 2006. And at that point, we highlighted the kinds of work studies that had basically been published relating to, or that had used nest boxes. Most of those had been conducted in a research context, but there was a small number where people were starting to use nest boxes in a sort of a management context where they're trying to use them to conserve or manage species. So, for example, a couple of studies involved translocations of gliders, specifically of sugar gliders. So if we go back all those years ago, there weren't that many studies that had been done, but there was, they were just starting to increase in popularity as we moved into the 21st century. Now, one of the interesting things is that all of the early studies were actually conducted in Victoria, and they're the ones I've highlighted here. And that might tell you something, that perhaps these researchers were concerned about the quality of the habitats that they were working in, or that they could see that animals that require tree hollows had lost out. But for whatever reason, they recognised that there was value in trying to use nest boxes to study a range of different hollow-using mammals. Now, my background in terms of nest boxes, the first nest box study I got involved with was with David Sharp. So David had already set up some nest boxes with someone from the National Parks and Wildlife Service before I sort of came on the spot. And those boxes had a range of entrance sizes, and basically the boxes weren't receiving much use by animals. So at some point, David and I converted those to all being narrow entry boxes so we could do a study focused on feather-tailed gliders. Then a couple of years later, the two of us were again doing some work, this time on squirrel gliders in Brisbane, and this became part of David's PhD work. And the site we're working at was managed by Brisbane City Council, and towards the end of the first year, they were suggesting that maybe we should use some nest boxes to assist the work that we were doing, and it might provide some insights for them in terms of other management of gliders around Brisbane. So we took that on board and started installing nest boxes. And before you know it, things sort of got out of control, where I ended up doing quite a few different nest box studies over the years targeting different species. And some of those studies were focused on trying to understand whether, design features of the nest boxes will influence, basically what you get in the nest box. Anyway, in recent years, there's been a number of studies published where they've been quite critical of nest boxes. And the criticisms that are levelled at nest boxes can be distilled into what I would call 5 contentions. So one is that boxes mainly benefit common species. Another one is that you often get a lot of exotic species like introduced birds and feral honeybees. When studies target species of conservation concern, they rarely get them in their boxes. Over time, boxes fall apart, fall off trees, so there are high rates of attrition. So if you were ever to use them in a management context, there's going to be high costs in trying to maintain nest boxes. And nest boxes, the temperatures inside can get can vary quite a bit with ambient, and as a consequence in summer when we have heat wave conditions, the boxes can get quite hot and therefore may be quite harmful if there's any animals inside. So I'm going to look at these contentions in turn using some recent data and specifically studies that I've been involved with. Now, just in the last couple of years, I did a review study for the New South Wales Road Agency, and the context of this project was that the Road Agency obviously had been doing a lot of duplication of highways in New South Wales, because there's, for 20 years at least, there's been an intention to try to turn the Pacific Highway north of Sydney into a dual carriageway road, whereas previously most of the area was just single carriageway. So there's a whole bunch of road sections that became separate projects. There's been a couple of other projects on the Hume Highway and also on the Princes Highway on the New South Wales South Coast. And typically when the road agency is duplicating a road or trying to take out a large bend in a road, they end up cutting through habitat that's got hollow-bearing trees. So what that has led them to do is that they now routinely install nest boxes. So they basically get consultants to do this. And the intention is, the main objective is to provide shelter sites when the identified road area where the new road is going in, when that gets cleared of trees, that there is somewhere for the animals that are displaced to find shelter. There's also some debate about whether they're using it as an offset, but primarily it's got that short-term aspect to it to provide shelter sites. Now, I was engaged to do a review of their nest box projects. So most of these projects had been conducted by private consultants. So I did that and then put the data together into a paper, because there was a lot of work that had been done as a consequence of a lot of projects. So I reviewed 16 projects, which included 1,865 nest boxes. There are also bat boxes installed in most, if not all, of those projects, but I don't refer to those here, even though you'll see on some of the graphs that there are some numbers there relating to that. Now, across these projects, there was basically at least 9 different nest box designs that were used, and I'll show some of the data. I won't show all of the data from that review project. The right-hand panel here shows boxes that have been given specific names, scansorial mammal, and the full names are shown on the graph. So a range of different names, and the boxes vary to some extent in their internal dimensions, but the key difference is really the entrance size. But you'll notice that there is overlap in the entrance size of a lot of those boxes. So it is one point of frustration to me that people will just give something a name and assume that it targets that particular species, when in fact it's often not very different to something that's given a different name. But anyway, it's a sort of reasonable starting point to try and gain some understanding. Now, what I'm showing here is the small gliders, which consist of sugar gliders and squirrel gliders, were one of the main users of the nest boxes across these 16 projects. And I might add that squirrel gliders were detected in 11 projects. So that issue about species of conservation concern not being fairly rare in terms of users of nest boxes doesn't really hold true. In these projects, there is the complication that a lot of the time the small gliders could not be identified to exact species. Part of the reason is that a lot of the checking was done using pole cameras, and also during the cooler months of the year, the small gliders tend to build fairly elaborate leaf nests, and often when it's cold, they'll have the leaves, in a ball over the top of them. So when you're looking in there to try and identify what's in there, often you might see some movement, you might see some grey indicating that it's a small glider, but you don't get a very good look of the animal. And to some extent, if you're looking at a video screen on a pole camera, it can be difficult to distinguish whether you've got a sugar or a squirrel. My reading of the reports that I looked at is that it looks like a lot of the records were sugar gliders, but there's certainly an undetermined number of squirrel gliders. But for our purposes here, it doesn't really matter, because what we want to look at here is, simply asking the question, do these different box designs target particular species? So in the case of the small glider box, it was the one used most frequently by the small gliders. The scansorial mammal was suitable in entrance size to, say, sugar gliders to some extent, and also, juveniles of both species. And what you find is that the gliders will use the small parrot box, which has a front entrance and a larger entrance. But once you start getting up to those much larger entrances, they're not so keen to use them. Keep in mind that at the sites where these boxes were installed, they tended to install one of each type, not necessarily 9 at one location, but they were installed in clusters, and a cluster would consist of one of several different types. And what's going on here, and this has basically been, this was sort of demonstrated to me from another project that I did, that most animals that use shelter sites of some type will not just rely on a single site. They need to move sites occasionally, and there's a number of reasons for that. One is possibly that they're trying to avoid just hanging out at the one site, which might make it easy for predators to find them. But perhaps the leading reason is that animals, particularly mammals, will build up loads of parasites, so fleas and ticks and things like that. And one of the easiest way to actually shake them off is to basically move sites. So what they like to do, and what you find, is that where you've got a preferred nest box with some less preferred other types of boxes, they'll spend most of their time in the preferred box, and then every so often they'll move to one of the other sites. They'll build a leaf nest, stay there maybe for a couple of weeks before they move back to their favoured site. So when you're checking the boxes, what you tend to see is you'll see a lot of these other boxes with nests, even though this is showing that, you do see gliders in these other boxes, but their preference is for that small glider box, which has the smaller entrance size. So the key thing with targeting species, it's all about entrance size, because species generally will select nest boxes that they can just squeeze into the entrance, because they're trying to minimise the chances of being disturbed by either larger competitors, so they might get evicted by, say, brush-tailed possums, and also to some extent they're trying to prevent predators from getting at them. So having a narrow entrance can help with that. Okay, what about common species across all these boxes? Well, certainly a lot of them were used by brush-tailed possums. And the brush-tailed possum highlights an important point here, and that is that what you find when you look at some of these, or a lot of these projects, people tend to put up a lot of boxes that are suitable to brush-tails. So once you've got an entrance size of about 10 centimetres diameter, you're going to get brush-tails. Across all of these projects I reviewed here, 28% of the boxes were basically ones suited to brush-tailed possums. So, the point I'd make is that if you're putting up brush-tailed possum boxes, don't be surprised if you get brush-tailed possums in your boxes. This photo here also highlights another point, which relates to exotic species. So the white areas around the inside of that box are basically remnant pieces of honeycomb. So let's look at what happened with the exotic species across these boxes. Basically, very few were used by black rats, so less than 1%. Very few were used by the introduced birds, the miners and the starlings. And relatively few were used by feral honeybees. And in fact, what you find is that most of the hives you find are actually inactive. Only 1% of boxes actually had active hives in. And what you tend to see is that the bees will occupy a box for maybe 12 months. I mean, we have had some that have been occupied for 2 years, and these are untreated boxes. But generally after 12 months, the bees, for whatever reason, depart the box. Potentially they just swarm and move somewhere else because they've filled it up completely. They can't grow any further, or the hive can't. In some instances, it looks like the honeycomb might have been eaten out by a beetle, so it's not clear whether the beetle is preys on the the eggs and the larvae of the bees. But invariably, what happens is that the mammals move in and clean up the honeycomb. So you really don't need to treat boxes that have bees in them. And to some extent, if in most projects that they provide more boxes than what get used, so to some extent there's always going to be redundant boxes. So it's not really a concern that a small percentage might get used and might have active hives in. If you're getting large, very large percentages, more than 10% or more, let's say more than 15 or 20%, then you might have a management issue that you need to deal with. Okay, what about threatened species? There were small numbers in those road projects, but that doesn't mean that threatened species won't use them. To some extent, the areas where those boxes were installed, most of them within a few hundred metres of the new road alignment, some of those areas either perhaps weren't that suited to use by, say, greater gliders, or in the adjoining habitats there was, and we know from the data that we collected, there were actually quite a few, there was a fairly high density of natural tree hollows. So when you've got species like fascicles, which have very large home ranges, and yellow-bellied gliders that have very large home ranges, if there seems to be a reasonable abundance or density of tree hollows in those areas, then it's unlikely you're going to get those species in the boxes. But where we have done targeted studies where there is a deficiency of tree hollows, we can show that you can get quite reasonable levels of use by threatened species like fascicles. So I've been involved with some work down in around Heathcote and around Bendigo, and what that work has shown is that you're getting somewhere of more than 20%, maybe up to 60% of boxes showing use by fascicles. And keep in mind that fascicles are not completely dependent on tree hollows, and you'll lose the males. There's male die-off in the middle of the year, so that will also mean you've got a lower chance of actually seeing animals in the boxes. In these studies that I've been involved with, we are getting maternity nests in these boxes, as demonstrated by that upper photo showing some young fascicles. Now, but also to come back to this point of, say, squirrel gliders in nest boxes, we've demonstrated this repeatedly in southeast Queensland and over a reasonable period of time. So in this particular study, we had nest boxes installed on private property. It was only a small number of boxes. It was a small-scale trial. But we were able to show that squirrel gliders occupied these boxes continuously over the 10-year period of our checking. And we did minor repairs of the boxes each year. Most of the time, we only visited the site once a year to do a count, to catch animals and tag them. But over the 10 years, we tagged over 100 squirrel gliders across these two sites. There were 7 individuals across the two sites that were present for 5 to 7 years, and we documented 66 breeding events. So, that demonstrates that a threatened species can use these boxes at sites where there are few, if any, tree hollows, and they're quite happy to use them. Another point of contention is which relates to nest box attrition, so boxes falling off trees. So I had the opportunity to look at this in detail with Karen Thomas and Debbie Shanty from the Friends of from the Bendigo Field Gnats. So there had been boxes installed by different people from that group over a period of years. And in 2016, Karen and Debbie went in and did a full audit of the boxes. So they were able to relocate or locate where something like 300 odd boxes had been put up, and they were able to record whether the boxes were still functional or not. And then based on the records that have been kept by others, we knew how long those boxes had been in place. So for boxes that had been in place for 10 years, there was more than an 80% rate of those boxes still being functional. I should point out that within the 3 years prior to the audit, none of these boxes had been maintained. For the boxes that had been put up for 25 years, none of them had been maintained in the previous 15 years. So it just highlights a very infrequent, and maybe you can stop it for long periods of time. You will still have boxes remaining functional into the future. They don't all fall down within 10 years. We identified in this study that the method of attachment can be important. A lot of boxes get nailed directly to trees, and because they don't allow for tree growth, within a few years, the trees start to pop those boxes off. We also identified there was a bit of a difference across species. So some species will grow faster than others, and therefore they're going to pop them off more readily than others. So a study I've been doing or collating with the Quinn twins, Bruce and Darren. Bruce installed 52 nest boxes in forest blocks north and south of Chiltern back in 1986. And then those boxes were monitored over more than 10 years. Subsequently, boxes were repaired and additional boxes put up. And basically, the boxes are still going after, or boxes at those sites are still in place and being monitored after 30 years. But what I've done here in an analysis is to look at the probability of annual use by just the squirrel glider. We do also have data for sugar gliders and fascicles. But what this shows is a very high percentage of use by squirrel gliders at these sites. So higher use on the north side than the south side, which appears to reflect differences in the habitat across those forest blocks. Now, what about the heat stress hypothesis? Well, basically, a number of studies I have looked at temperatures in nest boxes, including myself. And the studies are fairly consistent in that they show that boxes do vary with ambient temperature. The boxes can become quite hot in the middle of summer. But few of the studies have actually looked at boxes that have got animals in there. I'm about the only one that's done that. So people, because of this concern about how hot the boxes get in summer, they've highlighted that there's an issue here, and they've suggested that could lead to broad-scale mortality. But I've looked at this with some actual data. So using our box installation in Brisbane, so there was a period of about 5 or so years where we did a lot of regular checking of the boxes. I should point out that typically we didn't check boxes on a very hot day because, for one thing, we don't like to get very hot, but also, there are animal welfare issues, so you don't want to be pulling animals out of boxes if they're already heat stressed. But there were some checks done where the temperature the day before was reasonably high at about 35 degrees. So these animals have access to both tree hollows and nest boxes. So if they don't like it in the box, they can move out of it and go into a tree hollow. So I looked at that to see if there was any pattern to the use. So whether the temperature the day before actually influenced, how many of the boxes were occupied. So the left-hand graph there shows basically the number of boxes out of about 15 or so that were occupied. And then on the right, the number of gliders that we captured out of those boxes. So we did have quite a few gliders in there. It wasn't just a couple of individuals most of the time. And basically, though, the analysis of those data show that there's no influence of temperature. Now, another way to look at this is to look at patterns of animal survival. And I've done this at a couple of sites, and there's also some data from Victoria. Now, admittedly, we're looking at 3 different sites here. There could be a range of factors that vary across these sites that might influence survival rates of squirrel gliders. But the things we know about are that at one site, the Brisbane site, the gliders could use both nest boxes and tree hollows, and we know they did because of the work that we did. We did radio tracking and so on. Whereas at the site at the Sunshine Coast, they only had access to nest boxes, so they couldn't go anywhere else. And the site in Victoria, where Kylie Soanes and Rodney Vendery had worked, the gliders only had access to tree hollows. Now, when you do mark recapture studies, you can do some sophisticated computer modelling of the data, which allows you to estimate survival rates. And what analysis of these data show is that the survival rates across these 3 sites were basically not different because, the means are only marginally different, but the confidence intervals overlap quite broadly. And the key point here is that the data are not analysed from a very short period of time, like the Pomona data at the Sunshine Coast are based on 10 years of checking of those boxes. So, that is a real result, that there was very high survival rates of those gliders in those where they only had access to the boxes. And I should point out that, the Brisbane and the Sunshine Coast site, were prone to temperatures going up to 40 degrees on an annual basis, basically. Okay, how else can we look at this particular issue? Because one set of data, doesn't fully address the issue. So we've looked at it down at Bendigo, where it can get mighty hot sometimes. So Karen Thomas and the Bendigo field nets have got a whole bunch of nest boxes set up down there that get used by sugar gliders and fascicles. Karen and I looked at this in detail over the summer of 2018-19. So Karen would identify boxes that actually were occupied, and then we put data loggers in there. But what I'm going to show is basically the data based on some surveys of the boxes that we did. So May in a particular year is like the best time to do the survey because it's before the fascicle male die-off, so it's the time when you're going to get most occupation of the boxes. So we did surveys in May 2018 before that very hot summer, and then again afterward. The other context for this work is that there was some older work done in the lab to look at how different species responded to long periods of exposure to 40 degrees. And it was based on only one individual of different species. The Squirrel Glider seemed to do okay, whereas the fascicle, the authors were a bit concerned because the body temperature started to vary with temperature, so they basically cut the trial short. So let's look at the fascicle data, and what this shows here, that even after this summer where there were 10 days where the temperature went to or above 40, including to above 45 degrees on one day, there's no difference subsequently in the number of boxes occupied, and there was actually a slight increase in the number of individuals using those boxes. And I've standardised because there was an increase in boxes from one year to the other, I've standardised by the number of boxes. Sugar gliders, no difference either. The number of boxes occupied decreased slightly, but the number of individuals was around about the same. So based on that, and also based on the more detailed work that Karen and I did, where we were monitoring the boxes that the animals were actually in, we found no evidence of mortality. So you would expect, if animals were getting cooked in those boxes, you would find dead animals in the boxes or laying beside the boxes, and that just wasn't the case. And we had data loggers in there, so we could get records of animals coming and going based on just changes in temperature during the night, and we know that actually happened. So in terms of the nest box contentions, that they mostly benefit common species is not true, but it is true if you put up lots of possum boxes, you're going to get lots of possums. Exotic species, there are sites, some landscapes where there may be issues, but there's a lot of studies being done now where this really hasn't been an issue. So it must be just a specific issue at some sites for whatever reason, maybe very degraded landscapes. Species of conservation concern do use them. We get very frequent use by squirrel gliders and fascicles. High rates of attrition. It's not to say that boxes won't fall off trees or won't fall apart. You've got to take care in how the boxes are constructed. I've certainly constructed boxes that haven't lasted very long, so you need to source them from people that can produce quality boxes. You need to attach them in the best possible way that allows for tree growth. There's not really any ideal way for attaching them. We use fencing wire, but with a concertinaed area of the wire so that it can allow for tree growth. Okay, extreme temperatures. We do need to be concerned about high temperatures in nest boxes, but current evidence suggests that those high temperatures is not actually detrimental to the species that have been looked at. Okay, now nest boxes are not the only way forward. A lot of work's now being done with chainsaw hollows. There's a lot of merit in chainsaw hollows. So some of the deficiencies with nest boxes are dealt with by chainsaw hollows. So these hollows, because they're basically cavities in the tree, the temperatures in these cavities are lower than ambient and they're quite stable. So it overcomes that issue with nest boxes. You don't have anything protruding away from the tree, so branches that might fall down on nest boxes aren't an issue. But one of the things you do have that we don't know about is the maintenance requirements. So you still need to have some point where you have a cover to the cavity itself, and that cover will be screwed in or attached in some way, and that becomes the weak point. We also don't know whether the trees are going to grow over the cavities that have been cut. So the maintenance requirements we don't know about. And there's probably other issues that relate to what's going on inside the tree that we don't really know about at this point in time. But clearly there's a lot of merit in doing further work with them, and in many areas these may be a better way forward than nest boxes, but in some instances nest boxes can be put up and moved around quite readily. So there is a lot of flexibility that nest boxes provide, and you're not limited by tree size. Okay, now I'm going to move on to population monitoring. So I'll relate to or describe some of the work that we've done. Most of it based on trapping and spotlighting. We've used cameras for monitoring nest boxes, but not so much just for determining presence absence at sites or on transects. Obviously, we've done a lot of nest box work where we've tagged animals, and you can look at estimating numbers and survival over time when you do repeated recaptures. What we're going to be trying to do, I think, over time will be to look at populations and try and understand whether the populations are tracking along at one level or whether they're going down or going up. Obviously we want them to be going up if we're doing some positive sort of restoration of sites. Okay, how do we go about this? So one question that comes to mind is, should we be doing spotlighting or trapping? Is one better than the other? Well, to some extent it depends on the objective of your study. If you're doing a very small scale study where, you've just got one patch, then maybe, you might put up nest boxes, or maybe you put up cameras or something like that. But depending on the intensity and the scale of your project, that's going to influence the survey design that you end up adopting. In future, there will be a need for large-scale spatial studies so that we can get a better idea of how populations are trending based on surveys of a bigger component of a population. We've used conventional spotlights. In future, people are probably likely to be using thermal imaging cameras. But I'll describe some of the work we've done. So Brendan Taylor and I did a comparative study using spotlighting and trapping at a different site in Brisbane. So a 900 hectare site. We evenly spaced 36 transects across this urban remnant. The transects most of them were 200 metres long, and we evenly positioned tree traps on those transects. And we did surveys over 5 separate sessions over basically a 2-year period. And in each session, we did 1 night of spotlighting and 3 nights of trapping. And that raises the issue that, it's not that easy you can't really compare. It's not a fair comparison to compare 1 night of spotlighting with 3 nights of trapping. So what I've done here, I've used a multi-method occupancy analysis to look at estimating the probability of detection over the 5 sessions and over the 36 transects. And what this shows is that there's really no difference between spotlighting and trapping. It's, the probability of detecting gliders is around about 0.2 or 0.25. So 20 to 25% of the time you'll pick up a squirrel glider. But if you leave your traps in place for 3 nights, that's going to go up to about 40%. 40% of the time you'll detect them. So then you've got these trade-offs in terms of what's the cost of actually running a program for 3 nights versus 1 night. I mean, no one's really going to be trapping for 1 night. It's always going to be more than 1 night. But you may try and look at, we didn't look at it here, but whether you can actually get more detections for a cheaper investment if you do 3 nights of spotlighting rather than 3 nights of trapping. Okay, we have also done detailed trapping at various sites. So at our Menipi site in Brisbane, there's a long-term project that's been going there for about 18 years. I've still got a postgrad working there at the moment, trapping. There's been a long-term proposal for a housing development, which has gone ahead, which is basically in and around the cleared areas surrounding that bushland. But there is a part of that includes restoration of a lot of the habitat. So over time, the gliders will end up with more habitat. But the key issue here was to be able to estimate the size of the population and to see how it tracked over time and particularly how it trended once the development occurred. So in this set of data here, I was doing, in association with Brendan and Georgia Bayer, we were doing like mostly three sessions of trapping per year to be able to get reasonable estimates. The current work relies on 4 sessions of 4 nights, but that's probably more than what's really needed. But in any case, what it shows is that the number that you catch, so typically what we were getting here is what's shown by the dashed line, so somewhere of the order of 40 to 55 animals, whereas when you use an analysis program which estimates capture or recapture probability, it then estimates that the number's substantially higher than what you think, because there's always animals that just evade capture. So the number was about 20 or so higher than the number that we were simply catching and just counting based on tagging. But in any case, it just highlights another approach, but it's a fairly intensive approach, and it is an approach that has application in certain contexts. But if I was doing surveys across a much broader landscape, I wouldn't be applying this particular approach. Okay, what about post-fire recovery? Is there a role for nest boxes? So there has been a lot of people wanting to put up nest boxes after the severe summer of 2019-20 when vast areas of forests were burnt. And you can see a couple of examples here from the New South Wales south coast. My point here would be, and I've been advising some people that have been wanting to do this, that you can't just go out and start throwing nest boxes up, because some of these areas, even though wildfires will remove tree hollows, they can also create tree hollows, and they don't remove all tree hollows. So nest boxes are going to be most effective where there's a deficiency of hollows. So if there's a high density, and what I might define as a high density is at least 6 per hectare, you're probably wasting your time if you're above that. Certainly if you're above 8 per hectare, you're probably wasting your time putting up nest boxes, because they're simply not going to be used by your target species. So if you're concerned after a fire's gone through, you need to go in and do some sort of audit of the hollow resource that's present in the areas that you're looking at. These areas here, in these photos, there was a deficiency of hollows there. There are areas that have been logged historically, and I mean, you can look at the size of those trees. They're not very big, and there's very few hollows through that area. Now, the recommendations, if one was to be putting up nest boxes post-fire, and you're targeting squirrel gliders, these are sort of my recommendations here. That there's a lot of evidence now that shows that you need a small entrance nest box. It doesn't really matter what the internal dimensions are, but you need an entrance of about 4 to 5 centimetres. I prefer rear entry or side entry nest boxes. The front entry, you're basically forcing the animal to come out into the open and do a somersault to get into the box. They readily use front entry nest boxes, but who knows whether you're really exposing them to, increased predation that they don't need to be exposed to. Whereas with these other nest box types, they can readily get in and out of their nest boxes without, having to spend time more out in the open. Because there is an issue with temperatures in nest boxes, the nest boxes should always be installed on the side of the tree that's going to be sort of in shade in the late afternoon. So generally the east through to the south. And we started doing this in that very first nest box study I was involved in with David Sharp. We installed those boxes on the east through to the south because we knew what was going to happen. You only need to install them at 3 to 5 metres above the ground. There's a lot of people that want to install them very, very high. The reason I advocate this height is we know that squirrel gliders and other gliders will use them at this height, but also the key thing is it's better for safety of the people checking the boxes, whereas when they go higher, you really need to have an arborist who's using ropes to check, and then your costs go up. And once your costs start going up, people start losing interest in continuing their box projects. There's a lot of use of pole cameras now, but there's going to be a limit. You know, once you're up to about 7 metres, it's pretty hard to keep a pole steady enough to be able to look into nest boxes. And you really don't need them that high. We've shown you can get very high levels of use when the boxes are lower. And, you know, my experience is that they're going to get checked. People are going to be more motivated to check them when they're lower because, you know, either they can go in with a short pole camera or they can go in with a short ladder and have a quick look themselves. Typically, we would install the boxes in small clusters. As I was saying earlier, animals will need to move around to shake off their fleas and ticks. There's no set number how many you install, but if you put in 3, it allows a little bit of redundancy in case you've got other species coming in and taking over or chewing into boxes or whatever. And if you're putting in more than that, it's just going to simply cost you more money. You want to be putting out boxes so that you can reach, you know, more social groups or, you know, catering for multiple social groups. If they're too close, you could create some social issues where animals from different groups are coming into closer contact than perhaps they really want to when they're denning. Whereas if you're at 200 or more metres apart, that's maximising the chance that you're going to have different social groups. The study we did at Heathcote, because it was targeting fascicles, the box clusters were basically 700 metres apart, which ended up being really good for the sugar gliders that we got in those boxes. And the clusters, generally, you don't put the boxes on the same tree, but those boxes were you know, they could have been on adjoining trees, but typically they were like 20 to 50 metres apart. Anyway, they're my recommendations. So there is a role for nest boxes in degraded habitat, whether that is in a post-fire environment, you know, only time will tell. But basically, they're my recommendations, and that's where I'll leave it, and thank you for your attention.